Hello, and welcome to Klimatic Scale. My name is Dash. Urban industries at the heart of our economy need to change to stay competitive, and we need them to change for the planet to thrive. In Klimatic Scale podcast, we focus on examples of what actually works. In this urban chapter, we talk to innovators in built environment, real estate, and construction. We show the toughest challenges and the best working solutions. Our guest today is Brian Koch, CEO of Integra DNC, a construction startup that produces prefabricated building envelopes for energy efficiency. Can you just shortly introduce yourself? How have you come to work with built environment?
I'm Brian Koch. My profession is actually architect. So naturally, I work on the built environment, designing sustainable built environments, like sustainable buildings, zero energy buildings, even sometimes off-grid buildings as well. And so I've been practicing the architecture in the United States for about 27 years now. While I was designing buildings, I felt some gaps in the profession, in the industry, that we need new products, new technologies to achieve better sustainability. So I always kept ideas on my notebook. And one day I grabbed a chance to do R&D in South Korea, and it became just a business. I became entrepreneur of this startup. I founded in South Korea in 2018. So since then, I'm managing this company in South Korea, as well as I'm acting as an architect in the United States.
Can you share a little bit more about how has been your architecture journey? Did you fall in love with buildings, or was it an accidental profession?
Well, then I have to go back to my high school days. So I was into either arts or music when I was a high school student. And either I wanted to become a musician or some kind of designer. But when I had several meetings with the school guidance, school counselor at high school, the teacher just introduced me to architecture, which I never thought about. And then I kind of liked it because it's between art and engineering. I was very into mathematics as well. I chose architecture when I went to college, and I kind of liked it. But the biggest moment was actually after I graduated this college and I was practicing architecture as an intern. I had a chance to travel to Europe to see masterpieces of Le Corbusier's and other European architects. And when I saw and experienced those buildings, I just really fell in love with architecture. But now, I was also very technically oriented. So while I was designing it back then in 1990s, the term intelligent buildings, that was booming around the world. And I wanted to become like a designer who knows the intelligence of the buildings. I went to the United States to do the master's degree, the majoring the intelligent buildings. And then when I studied this, it was all about the automated buildings and smart buildings, we call it these days. And I just realized that it should be more than just automation. So then I expanded my study to green buildings, and then that's how I fell in love with the sustainable architecture.
Anything else in built environment in general that you like, that you find really interesting trends? Not necessarily new trends. It can be something that has existed also for a while, but something that you believe in.
Well, yeah, of course, the building science. So we call it like either building science or passive buildings. How the building envelope reacts to the climate. That was my focus when I studied the masters, and just the way that the designers design the buildings, especially the appearance of the building, is very important for the architects. But however, not many architects actually knew about the building science. But I really wanted to follow this wisdom of the modern architecture called form follows function, right? So when I designed the form of the building, I really wanted to focus on the function, but not only just the spatial function, but also actually the way that the building reacts to the climate. That's the function that I defined. So then I really focused on how large the window should be, how thick the insulation should be, and all kinds of factors that affect the appearance and the envelope of the buildings.
This is a perfect segue to talking about the challenges in the built environment. Maybe you can share originally, before you started in your business, what type of stakeholders you were working with and what you have learned about their problems, their challenges.
Well, yeah, as I said, just I was really into the building envelopes. And when architects present their ideas, their designs to the clients, usually we show like 3D renderings, nice, really nice 3D renderings with nighttime view with all the lights on and
yeah, very pretty,
very pretty buildings and stuff. But in reality, especially in modern days, a lot of architects love windows and glasses. So, whole building, like a big tower, is covered with a curtain wall system with 100% of glass. If you are into energy simulation, always the glass is the worst material in terms of energy conservation and stuff. Architects love for the windows and glasses and then these kind of cool renderings. Usually clients accept it as kind of attractive buildings that they can own and they can use. However, as soon as they hear about the energy side, it's conflicting each other. And I saw that issue a lot. And even if I present cool renderings and then present the energy numbers, it shocked a lot of clients. And as part of my career being sustainability advocate, I didn't really want to use just a cool looking windows and stuff. I always wanted to have numbers back up my design.
How do real estate developers who already have experience with that, how do they fall over and over in this hole of, okay, choosing the pretty looking project or something modern looking?
They are not informed very well. Architects usually do not run energy modeling. It's usually done by the mechanical or energy engineers. They did not understand the way they design impacts certain numbers of energy. They do not have that correlation in their minds. So the energy simulation used to be done more like afterwards. So like after the design is done, then they just provide the numbers as kind of fact. But more and more these days, the architects are now into these energy issues, and then they now work with engineers from the beginning of the design, even before they start sketching up something on their iPad or something. So I think it's getting better. And also the developers and building owners are now being more aware of that issue, but I don't think still there's a full level of education yet. Just imagine yourself, you are a building owner and you have a really nice view, top floor office as a CEO, and then full window around you, your office, and you look out the city of Berlin, and that's cool. But so you love that spot, but in 10 minutes, if the sun hits your desk or your body, then what you usually do is, okay, this is uncomfortable, so I gotta put the blind down, right?
Yes, exactly.
Usually people do that. And then so that 10 minutes of loving the view is going away very quickly, and then just you are more uncomfortable. And then people have a habit that once they pull down the blinds, usually they don't pull that up again. It stays down. It stays down a lot of time. Then what's the point of having big windows? Like you are looking at blinds, right?
That's so true. Brian, I had actually this situation. I was running a top floor co-working space. It was so sunny, so amazing. And then I learned the hard way that everyone is working with their laptops, and actually light is not good at all for you. So everyone was like hiding in the darkest corners of that space. But is there, do you think, a kind of conflict of interest almost between real estate developer and the facility manager?
Maybe not among those two stakeholders, but rather I think the building owners and facility managers and the users of the so as I said, if it's cafeteria, like people sit 30 minutes, they do not usually work. They just drink coffee and then chat. Probably having the sunlight is okay. But if it's an office, a school, I mean, the visual task is more important than just looking out the window. So the building owners and the architects should have this mindset of providing the best environment for the building users based on the function of the building. And then as an architect, I designed a lot of school buildings from the kindergarten to middle school and high school, and also some college buildings and some office buildings and residentials as well. And when I designed especially the school buildings, I learned a lot how the building envelope should function for the students and the teachers for their learning environment the best. So it's not providing huge windows and huge lights. It's got to be very optimum size of windows. Even when I bring in the sunlight, it's got to be distributed sunlight. It's called daylight. So no direct sunlight should hit their eyes or their computers or the whiteboard. And so we have to design the windows very carefully to provide that environment. That's how I fell in love with designing optimum envelope of the buildings, depending on the function of the building.
So you really took the needs of the users also into account.
Yes.
Right. And based on the specific use, be it a school or an office, it's also different, right? That's really interesting. Can you maybe share a little bit about your startup, your solution, and how exactly it is solving these challenges?
My startup is called Integra. I named the business from the English word integration or integrate. So architecture is basically integrating a lot of different principles, right, into the building. When I design buildings, usually the building, because of the nature of the building being so complicated, a lot of experts like engineers and architects and even other stakeholders and consultants always have their own expertise. And architect's role is not just sketching up cool looking buildings. It's architect is more like a conductor of the orchestra. Basically, he or she has to know every instrument and every player in the orchestra and then create this harmony. I loved being an integrator and I loved being a facilitator. That's why I named this company Integra. And my goal was, okay, there are a lot of cool technologies, there are a lot of geniuses out there that they develop unit technology, I say. But then I wanted to become an integrator of those various technologies to a new combination, new assembly that can help sustainability, that can help the carbon neutrality of the buildings. That's why I named this Integra. The product that I am introducing to the world right now is called IUES. It's an acronym of Incremental Unitary Envelope System. So again, it's about building envelope.
Yeah.
Now you know why I sell this product now.
Yeah.
Yes. So and it's a unitary modular product that can be installed very fast, that can be very energy efficient, and also especially I developed this product for existing buildings. So when you remodel or retrofit existing buildings into a better buildings in terms of energy efficiency, the envelope is very, very critical. And I wanted to create a product that the owners of existing buildings can adopt to really easily and also cost effective. And also when they remodel their existing buildings, it can be done very fast. So they can remodel and then have the people back into the building very fast. That's why I created this product using off-site construction, meaning that we don't do on-site. Everything is done like at the factory as a kind of product. And then we can install this modular units, IUES, onto the buildings very fast.
And it's it's installed on the facade, correct?
Yes.
It's installed over the facade. And can you share maybe some of the perfect examples when this is needed?
Okay. Let's imagine a school. I don't know about your schools that you went, but when I went to the middle school and high school, it was new, relatively new buildings when I was in high school and middle school. But if I go to my schools again, still it's almost like same. So it's 30 years, 40 years old.
Mhm.
And very energy inefficient. Back then, I'm talking about South Korean example, but probably many other parts of the world the same. Usually back then it was like single pane glass, things like that. So very cold or very hot. And then also back then, not many buildings, other than very advanced countries, had air conditioning or ceiling heating system. Okay, the mechanical heating and cooling systems were not there. So those buildings were built in terms of the floor to floor height. And if you want to add modern cooling and heating system into those old buildings, then you have to add new boiler, new chiller, and you have to create a new mechanical room somewhere, some in the building. But then you have to have a duct and also a lot of pipes inside of the ceiling, right? Then your ceiling height becomes lower and lower because of that system. That kind of makes building owners hesitate to implement renovations and retro. I thought about how we could solve this problem, and basically my IUES system integrated heating and cooling and ventilation units as a part of the wall. So let's imagine school buildings like a classroom. And you have 25 kids there inside. And if we want to add a new cooling and heating system and also change the windows and change the insulation, basically we can just remove the exterior walls and leave the structure in. Then by adding my units to the walls, basically you can have now optimum size windows, optimum insulation, and then also heating and cooling and ventilation system on the wall. That's very easy to remodel. Even I thought about, okay, if it's a school, then they have a summer break of 2 months. And what if we can finish the construction only in that 2 months? Then they don't have to move to temporary classrooms.
Yeah, wow. That's also so this is retrofitting, and it's often about insulation, but also integrating heating and cooling systems seamlessly. Are you also integrating other solutions, for example, smart solutions for energy efficiency evaluation?
Yeah, that's a very good question. So, in order to improve the energy efficiency by creating this product, it's also two ways, like passive ways and active ways as well. And as I said, I'm using kind of really a thermally broken energy efficient frame. And also windows can be triple glazing with argon gas in it. So very energy efficient. And also insulation is thick enough to be even able to install and meet the energy codes in Germany or Nordic countries. In the active system, as you said, it's got to be smart technology as well. So when I introduced this HVAC system as a part of the wall, I'm not the one creating the new HVAC system. As I said, I'm just integrating the technologies that somebody already has developed. I'm working with a mechanical supplier, and then they have their own control algorithm, control system. Every HVAC system these days are called smart controls anyway. But we wanted to become more smarter than just typical control system. So what we developed is, have you actually, let me ask you, when you were in co-working space, have you felt that it's a little bit hotter or colder for you, although the thermostat is automatically controlled?
Absolutely.
It's like that. And even if the thermostat is the new system and it adjusts the temperature accordingly, the problem is people are not same. Some people feel a little colder, some people feel a little hotter. So in the academic world, for the satisfaction ratio, if you can satisfy about 80% of the people in the same space, that's kind of considered as really good system. Okay, you cannot satisfy 100% of people. But a lot of cases in offices and schools where more than two people share one thermostat and one control, if you survey people, usually the satisfaction rate goes down to 60%. And that means 3, 4 people in 10 people like feel uncomfortable. So what we created is, okay, is there a way to find that 80% threshold? And in order to do that, you have to know who's in that space. So we created an app called METI, METI, which is my environmental type indicator. So basically, it's a kind of MBTI thing, and
Yeah.
basically we survey people's preference and their behavior, normal behavior, and then we categorize people into 8 different types. And among those 8 types, if type A are like 3 people and type B are like 5 people in the same room, then our algorithm can calculate which temperature is the best for those 8 people.
Can you share a little bit about how do you actually deploy your solution? Have you had any successful pilots already?
Yes, yes. So I did maybe four pilots in South Korea, and among those, 2 of them were very kind of small scale when we started testing this. But the 2 bigger projects were like one was a renovation project, and the other one was a new construction. Both of them were office buildings in South Korea. And the first building was a 5-story office building, and we installed IUES on the 4 stories out of 5. And the area, in terms of the area of the IUS installed, was around like 240 square meter, 4 stories. And we came in and on the first day, and then started preparing the work. And then on the 5th day, so it took like 4 days. Then we finished the exterior walls, and then we just moved out.
Oh,
So,
wow.
which it should have been, if it were a conventional construction, it could have been around like 2 months. But we quickly dried in the building like in 4 days, and then we moved out. And from that point, everything was done inside of the building. The second project was even larger. It was a 3-story office lab building, and we installed 360 square meters in 3 days. So that shocked not only the building owners, and we promised it, and they didn't believe it. I mean, because although they let us do the work, but they didn't believe it. But really, we have a time lapse video that I can share with you later, or
We can
see.
add it to the Substack for the audience
Okay.
to watch.
Yeah, it took only 3 days, and
Wow.
yeah. So then, what it gives of the benefit is it's not calculated in the construction cost, but when they construct the buildings, usually they have to dry in, meaning like they have to install an exterior envelope first to start doing the work interior, right? Otherwise, if they do interior work without exterior walls, then if rain comes in or if the temperature goes down, then the interior work is damaged a lot. So usually that's kind of critical path, the way you build the buildings. And this system also gives the benefit to the constructor, contractor, builder, because they can start the interior work just very fast.
What were the selling points that worked best for the customer? When did they have this aha moment of, wow, okay, we really want to work with Integra?
Let me tell you, this is how the government's incentives and government program kind of helps startups. So we developed this product using government funding, South Korean government funding, as an R&D. So when we do R&D and when we create these kind of new technologies through government R&D, usually getting the POC projects is easier, because then usually we can pick government-owned buildings. It's government money, tax money, so they have to be very careful spending tax money to create buildings. It's not small products that you can just refund, right? There's no refund in the built environment. So I had to persuade, and our R&D team has to persuade these government-owned building owners, and but it was very successful in terms of in terms of the selling point was again like if you install this product and then we can shorten your construction period this month. That was kind of first selling point. Second point was like you could save money because of the shortened period of time and the efficiency of our products, and we can actually reduce your construction cost this much. And then it was kind of selling points.
So basically, energy cost reduction, correct? So that's
Well, Dash, I love to talk to people like you who are concerned about energy and climate. Then my first selling point is always, okay, this is gonna save the earth. This is gonna be saving your energy and it's gonna impact your carbon footprint and things like that. But when I work with the general public and
Yeah.
general building owners who
Yeah.
are less concerned about those issues, I do not emphasize energy efficiency much, no, because that's not selling point for them.
Yeah. What is?
Like I said, okay, your construction period, if you do conventional way, then it's going to be 24 months. But if you use my system, it's going to become 20 months. So you will have 4 months faster. You're going to have your building 4 months faster. Then you can start selling your space and leasing your space 4 months faster, and you can start making money faster. And the other thing is, and not only the construction costs, construction period, but also construction cost. Again, like every builder, every building owner loves to hear about saving the money. But so that's my two selling points if they do not have concerns about the environment. If the client has concerns about the environment and sustainability, then I emphasize more on that side. And that's why I loved being in Europe. Europe has way advanced knowledge and way advanced regulations about the sustainability, right?
Yes.
So it's much easier for me to talk to people about the benefits in terms of energy efficiency.
It seems to me that in Europe, the situation is often very similar. The energy costs are more bothering facility managers or someone who runs the building, basically. The costs fall on them. There's a conflict of interest between who builds the object and who runs it. And for real estate developers, often it's a lot about the value of property, right? It's the value of the objects. Understand that when they already have decided to refurbish, your product has advantage of being so fast and generally more cost effective. But why, from your experience, why do they even decide to refurbish in the first place?
The building owners and developers, they see the building value as the first kind of motivation of the investment. And refurbishment or renovation motivation usually comes from that aspect as well. So if they want to increase their lease and make more money, and then instead of being follower in the market, they want to be the leader in the market and lease out at the higher price and lease out faster. Sometimes they are stuck. The building owners are stuck with all the buildings. Okay, I have no choice but keeping this just as running, because if I want to renovate and then increase the value, still my floor to floor is so low and I cannot add things up, and people are not going to like my space because it's going to be so shallow. Or maybe they say, well, I don't know what's behind the existing wall. If I touch something very sensitive, then it's going to cost me fortune. And so they have those kind of fear, I think, or roadblock that they face, that they cannot even start the renovation. So the new technologies, I mean, I'm not saying that IUES is the only one, but there will be new technologies and new people introducing new things that will make them decide easier in terms of renovating their buildings. That's what my hope.
The stakeholders you have been talking in the built environment, what have been your observations? What do you think can be done better so that the buildings they create, they refurbish, are better for the users, better for the energy use, and better for also environment?
I don't know every stakeholder in the built environment. Instead of speaking about each of them, let me tell you an interesting story that I
Mhm.
had. It was an elementary school that I designed to be LEED certified certification level platinum, which is the highest
Mhm.
level. It's in the mountain area of the United States, and uh, we started the design process a little differently from other conventional buildings. It was an existing school, so there
Mhm.
were already teachers, there were already parents. So we invited the teachers, parents, and even the community members,
Mhm.
firefighters, police, and even the neighboring church
Wow.
members. And so we had a big workshop, and we announced, okay, we are starting this project and we want to involve all of you. So you
Mhm.
are interested in this project. Every step that we advanced, like in terms of the design, energy numbers, and even the building layout, the appearance, we invited them back to the workshop many, many times. And then we shared the ideas, and even we had kind of hands-on workshops that they
Mhm.
could participate in. And also, we educated teachers a lot in terms of achieving the sustainability and choosing the materials correctly. We educated them. And then at the next session, they came back with their own study and then they had their own ideas. Sometimes, as a non expert, they had crazy ideas. But a lot of times, actually, it was really worthwhile to listen to them.
Mhm.
And also, believe it or not, we invited the fourth grade and fifth grade
Oh,
students as well.
nice.
We surveyed them like what kind of school we want to have, and I still remember one funny answer from the fourth grade a kid. I want to have a big pool with dolphins in it. That's
That's a great idea.
but anyway, so that was a lot of meetings and a lot of exhaustive effort, of course, in terms of the architect. But I really wanted to integrate everybody's idea as much as possible to create the most sustainable school in the state. And it works. And even because of that education and involvement of that
Mhm.
parents and community, uh, when the school board changed and the new school board members wanted to give up all the efforts and then kind of go back to like very conventional school design, and so they wanted to lower the standards. All the parents who
Mhm.
were part of this process,
Yeah.
they went to the board meeting and they really demonstrated and picketed everything, saying, no, we want this school. This is our
Yeah.
school. This is the school that we designed, not the
Mhm.
architect. We all designed together.
Yeah.
So they advocated this building, and then it was very successful that they protected the school
Mhm.
design, and finally we built it. So that experience taught me, if you share and transparent to all the stakeholders, present the numbers. If it's bad, then just show the bad numbers. That's as long as they are involved, as long as they
Mhm.
are informed, then I think they make really nice and good decisions. The building owners, sometimes, a lot of times, they count the money first, but eventually, if you spend more time with them, having these kind of conversations and educate them, many of them, not all of them, but many of them will actually buy your ideas and buy your logic. So that's my experience.
Oh, I love this. It's a very sunny idea. It gives a vision of a really beautiful future when we involve people who use the building into the design of the building. Is there anything you would like to share with other startups in built environment? Something that you think everyone should know and you would like to share with them?
The built environment or building construction industry is known as the most conservative,
Yes.
the most slow changing industry. And that's why I think the entrepreneurs are hesitating to get into the built environment startup.
Mhm.
And however, I think that if you flip that theory, and then I think that means we have huge opportunities. If you look at AI industry these days, it's highly competitive, and it's
Everyone's
changing
in there.
every day. Yeah, and then it's changing every day, and so if you don't develop your product like in 2 weeks, then probably you are behind. But because the construction industry is very slow, you can take time. You can develop your ideas slowly, but that's still the market is going to welcome you. So I think the persistence and your effort to focusing on your one solution, still the market is going to be ready for you to receive that idea. So let's look at the construction industry as the biggest market that has not changed much yet. Not only this product, but also I'm developing other products as well, and also even the software and again, like I love being an integrator of a lot of things. So hopefully I can introduce more technologies and more products in the future. But I welcome my colleagues around the world. Let's do it together, and let's solve a lot of problems that we have in the construction industry.
This is wonderful. Yes, there's lots of space in the built environment still to do. Thank you, Brian.
Okay, well, a pleasure being here.
Thank you for listening. Subscribe to our podcast on Spotify or Apple Podcasts. We're everywhere. See you next time.